So hi children, in this video we are going to discuss that problems from that worksheet 1. Okay, this worksheet 1 related to that concept 1 problems. Okay, so see that if a square number ends in 6, if a square number ends in 6, the preceding digit is, so what about this one? So here square number they are saying no, so square number ends with 6. When you will get that 6? Okay, just see that 4 into 4 is there, 4 4 is 16. 4 into 4 is equals to 16. So this number, this square number is ending with 6 or not? Okay, so this square number is ending with 6. And in the same way, another number is there. What is that? 6 into 6. 6 into 6 is equals to 36. So this number also ending with 6. So how many possibilities are there? The number which is ending with 4 or 6, then only we will get in its square, we will get that 6 in its last place digit or units place digit. Okay, so here 4 into 4 is equals to 16, 6 into 6 is equals to 36. Take that another number. What is that? That is 14 into 14, which is equals to 196. Clear? Next, if you want to take that any other number, then 16 into 16, which is equals to 256. Clear? And so on, you can take that any other number. So why I am writing this all means, when you observe these all squares, these all perfect squares, each and every number is ending with the digit 6 only, no? Each and every number ending with the digit 6. Okay, now come to that question. What they are saying, if a square number ends in 6, if a square number ends in 6, it's a preceding number. So they are saying about that preceding number. So preceding means just before digit, just before a digit. So that digit, what that is? First one they are saying even number, another one odd number, next one prime number, next one composite number. Okay, so here they are asking what about that? It's a preceding digits. So when you observe that here, this number 3 digit number, so 6 preceding, which digit is there? That is 9. Here 6 before which number is there? That is 5. So when you observe these preceding digits, here we can say that 1, 3, 9, 5. What we will call these all? These all are even numbers. No, this is not an even number. Okay, these all are not even numbers. Next, odd number, just keep that one aside. Next, prime number. Here 3 is a prime number, 5 is also a prime number. 3 is a prime number, 5 is also a prime number. But what about 9 and 1? 1 is not a prime and that is not a composite also. Okay, so 1 is not a prime and in the same way 9 is also not a prime. Okay, that's why here we can't say that that is a prime number. Sometimes we will get that prime number. Okay, so that's why here we can't say that that is a prime number. Next, composite number. If that is not a prime number means that is a composite number only. Oh, yes or no? But here what about that 1? 3, 9, 5 are composite numbers only. But what about that 1 here? 1 is that a composite number or a prime number? That is 1 is neither composite nor prime. That's why here this one also we can't say that one as a composite number. Okay, so which option is correct here? That is option B, an odd number. Option B, an odd number. So in every case we can observe that odd number here. Okay, let us see that next one. Okay, next second question say that here x power y is equals to y power x is equals to 256. Okay, x power y into, sorry, here that is x power y into y power x is equals to 256, is equal to 256. Now what they are asking here, 256 expressed in this manner. What is that? X power y into y power x. In this form we have to express this number. Okay, after just find that the what is the value of x plus y whole square. X plus y whole square. Okay, so first write that prime factorization. When you observe this form, this is just like the prime factorization only, no? So write that the prime factorization of 256. So 256 is divided with 2. So 2 into 128 is equals to 256. Okay, next 2 into 64 is equals to 128. Next one, 2 32 is 64. Next 2 16 is 32. Next 2 8 is 16. Next 2 4 is 8. Next one is 2 2 is 4. And the final one 2 1 2. Clear? So just observe that 1 2 3 4 5 6 7 8. 8 times 2 repeated here, which means 2 power 8 value is equals to 256. Okay, but here this number should be expressed in that form is x power y into y power x. In that form we have to convert. Okay, so I am going to take that one as only one method is there, that is 1 2 3 4. Okay, so I am going to consider this one as 2 power 4. First I taken a half of that one. Okay, that is 2 power 4, and the next one I am taking this one as 2 into 2 is equals to 4, and 2 into 2 is equals to 4. Okay, first I written this is in the form of x power y. So here x is equals to 2, y is equals to 4. Okay, now here this is what? Y power x. So what is the value of y here? That is 4. And what is the value of x? That is 2. Just observe that here 4 and here 4. How many times repeated here 4? 2 times repeated. Is it satisfying or not? That is satisfying, no, this condition. Which condition they given? Okay, so now this is in the form of x power y into y power x. Okay, which is equals to the value 256. Now from this one, what is the value of x here? X is equals to 2 and y is equals to 4. Now what they are asking? Just we need to find the value of x plus y whole square. So x plus y whole square is equals to x is equals to 2 plus y is equals to 4. Its square is equals to 6 square, which is equals to 36. Which is equals to 36. So which option is correct here? That is option C. Okay, which option is correct? That is option C. Okay, let us see that next one. One of the following which is not a perfect square. One of the following which is not a perfect square they are saying. So here we can use that properties. What is that first property? Maybe here we can use that first property. What is that first property of a square or a first property of a perfect square? A square number never ends in 2, 3, 7, 8. Okay, so just to check that here 9 is there, maybe that is a perfect square. Here also 9 is there, maybe that is a perfect square. Here 5 is there, that is also maybe a perfect square. But here what is that question? Which is not a perfect square they are asking. Which is not a perfect square, which means the remaining all are squares only, no? So remaining these three are perfect squares. Which is not a perfect square? Here option D, that number ends with 3. What I said that a number, a perfect square never ends with 3. 2, 3, 7, 8. In that group 3 also there, no? That's why this is not a perfect square. That is not a perfect square. So which option is correct here? That is option D. Okay. Let us see that the next one. The sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 and so on up to 27. So 1 plus 3 plus 5 plus 7 plus 9 plus and so on up to 27. So when you observe that these all numbers, here we can observe that these all are odd numbers only, no? Observe that 1, 3, 5, 7, these all are odd numbers or not? Odd numbers only. Okay. So here these all are odd numbers, but how to add that these all numbers? I will tell you one example here. See, 1 plus 3 plus 5. 1 plus 3 plus 5. Here I taken only 3 odd numbers. First 3 odd numbers. So after taking these 3 odd numbers, add these all. 5 plus 3, 8. 8 plus 1 is equals to 9. 8 plus 1 is equals to 9. So here how many odd numbers I taken here? 3 odd numbers I taken. So we can express this one as 9. We can write that one as 3 square also, no? 9 we can express it as 3 square also. Okay, 3 square is equals to 9. How many odd numbers I taken? 3 odd numbers I taken. So 3 square is 9. Its sum is also equals to 9. Clear? This is also one of the property only. Okay, so I am going to take that another one. 1 plus 3 plus 5 plus 7. But this formula we have to apply for that first n odd natural numbers only. Okay, so 1 plus 3 plus 5 plus 7. So which is equals to how much? 7 plus 3, 10. 10 plus 5 is equals to 15. 15 plus 1 is equals to 16. Okay, so 16 we know that that is a perfect square. To the square of this number we can express it as 4 into 4, which means 4 square. Okay, now here how many odd numbers we taken here? 4 odd numbers only, no? So we can express this one as 4 square. So from this one, what is that conclusion? Here 1 plus 3 plus 5 plus and so on. 5 plus and so on up to n odd natural numbers. Odd natural numbers, its sum is equals to, its sum is n square. Its sum is n square. Here n means what here? N is equals to, that is not the last digit. Here n is equals to how many numbers are there? N is equals to how many numbers are there? Here last number, for example here, that is 27 they given, no? So up to 27 how many numbers are there? That one represented by n. Okay, so n odd natural numbers and so on. Here they given 27 is the last number. So these many n odd natural numbers are there. Then how to find that sum of these all odd natural numbers? So the formula is n square, and this one we have to apply for only the when it is possible the sum of first n odd natural numbers, which is equals to n square. Here n is equals to number of odd natural numbers given. Number of odd natural numbers. Okay, now here see that question. What is that question? 1 plus 3 plus 5 plus 7 plus and so on plus 27. So 1 to 27 how many odd numbers are there? Already we know that how to find the number of odd numbers. So we can write this one as 27 plus 1 by 2. If the number is odd, then we have to add 1 and divide by 2. Then you will get that how many odd numbers are given by 2. So here we are having that 14 odd numbers are there. How many odd numbers are there? 14 odd numbers are there. Therefore here n is equals to 14. N is equals to 14. Now here what is the sum here? Sum of this one is equals to 14 square. Why? Because this is n square no formula. That's why that is 14 square, which is nothing but equals to 196. 14 square value is 196. So which option is correct? Yes, option C is correct here. Okay. Next. Okay, let us say that the next one of the following which is not a Pythagorean triplet. Okay, already we discussed in that synopsis about that Pythagorean triplet. So use that formula here, use that conditions here, and you have to check that which one is not related to that Pythagorean triplet. What I told you that, for example here the numbers are m, n, p. Here like this a triplet is there, then here the condition is what? M square plus n square, that is equals to p square. That's what we discussed in that synopsis, no? So n square value plus n square is equals to p square. Then only we can say that those are related to Pythagorean triplet. Okay. So first one say that 14, 48, 50. Okay, let us see that 14. So 14 square plus 48 square, which is equals to 50 square. The sum of the squares of each number, okay, to that first two squares of that, the sum of the squares of that first two numbers should be equal to that square of that third number. Okay, that is called a Pythagorean triplet, no? So 14 square is 196 plus 48 square. 48 square is equals to how much? Just take that multiplication. 48 into 48. 8 8 is 64. Next 8 4 is 32. 32 plus 6 is equals to 38. Next 4 8 is 32. 4 4 is 16 plus 3 is equals to 19. So here 4. 8 plus 2 is 10. 9 plus 1 10. 10 plus 3 is equals to 13. And here 2. Okay. So 2304, which is equals to here 2304 plus 196, which is equals to 4 plus 6 is equals to 10. 9 plus 1 is equals to 10. 3 plus 1 is equals to 4. 4 plus 1 is equals to 5. And here 2. So 2500. So this is sum is equals to 2500. And here 50 square is there. So 50 square how we can write? 0 into 0, 0, 0 into 5, 0, 5 into 0, 0, 5 5 is 25. Okay, so 2500. So here also we got that 2500. So here both also having that same values or not? So sum of the squares of first two numbers is equal to the square of the second number or not? So it is satisfying or not here? So this is satisfying. So this is a Pythagorean triplet. That is a Pythagorean triplet. Next check that next one. Here just we have to go for that options only, no? So next second one. Okay, let us say that second option, that is 22, 120 and 122. So this is a Pythagorean triplet or not? So 22 whole square plus 120 whole square, which is equals to 122 whole square. So it is satisfying or not? So 22 into 22 is equals to how much? Do you know that value here? If you don't know, then do this one. So 22 into 22. So 2 2's 4, 2 2's 4. And again 2 2's 4, 2 2's 4. So 484. Okay. So this is a 484 plus 120 into 120. How we can write that? 12 12 is 144. And here 0 2 times multiplied. So 2 times 0 you will get. Which is equals to, first add these two here. 14,400 plus 484. So after addition here you will get that one. 0 plus 4 is equals to 4. 0 plus 8 is equals to 8. 4 plus 4 is equals to 8. And here 4 and this is 1. So 14,884. Now we have to check that what is the square of 122. So 122 into 122. 2 2's 4, 2 2's 4, 2 1's 2. Now multiple with this one. Next 2 2's 4, 2 2's 4 and here 2 1's 2. Next again with 1. 1 2's 2, 1 2's 2, 1 1's 1. So 4, 8, 8, 4, 1. So here we got that 14,884. 14,884. Now here is it just to say that this is a Pythagorean triplet or not? Again we are having that these two having same values, no? Sum of the squares of first two numbers is equal to that square of the last number. I mean square of that third number. So it is satisfying or not? So this is also Pythagorean triplet here. That is also Pythagorean triplet. Okay. Now check that option C. Okay. Option C, what is that? 18, 79, 82. So check this one. 18 square plus 79 square is equals to 82 square or not? Okay, just we have to check that. So 18 square is nothing but 324. We know that. Plus 79 square. So 79 into 79. So how much you will get here? So 9 9's 81. 9 7's 63. 63 plus 8 is equals to 71. Okay. Next is 7 9's 63. 7 7's 49 plus 6 is equals to 55. Okay. So whole by 1. 3, here see that 1 plus 3 is equals to 4. 7 plus 5 is equals to 12. 5 plus 1 is equals to 6. So what is that result here? 6,241. 6,241. So if you add that these two numbers, what you will get here? add 324 to that is 6241. So what you will get? 5, 4 plus 2 is 6, 2 plus 3 is equals to 5, and here 6. So after adding these two, we will get here 6565. Okay, now see that this value here 82 square. So 82 into 82, by seeing only we can say that 2 and 2 means that number is ending with 4. Okay, so 2 2s 4, 2 8s 16, 8 2s 16, 8 8s 64 plus 1 65. Okay, so 4, 6 plus 6 is equals to 12. Okay, 5 6 7, and here 6. So which is equals to 6 7 2 4. Just observe that here these two are having that same values, not having. Here sum of the squares of first two numbers not equal to that square of the third number. That's why this is not a Pythagorean triplet. This is not a Pythagorean triplet. So let us check that next one. Here we got that answer, but we have to check that option D also, no? So check that option D. Here 10, 24, 26. Okay, so here 10 square plus 24 square is equals to 26 whole square. Okay, so 10 square is equals to, we know that 100, plus 24 square is equals to how much? Do you know that? You have to learn, but here if you don't know, then follow this. 24 into 24. So that is 4 4s 16, 4 2s are 8 plus 1 9, 2 4s 8, 2 2s 4. So 6, 17, 576. So this value is equals to 576. Is it clear? Now here 26 into 26, how much you will get here? Just see. 26 into 26. 6 6 36. 6 2s 12 plus 3 is equals to 15. 2 6 12. And here 2 2s 4 plus 1 5. So 6 7 6. 676. Okay, 26 whole square value is equals to 676. Now add these two numbers, what you will get? 576 plus 100, 676. So here you are getting that the sum of the squares of first two numbers is equal to the square of the third number or not. So it is satisfying or not. So this is also we can say that a Pythagorean triplet. Now what is that question? One of the following which is not a Pythagorean triplet. They are saying that out of the 4 options, one of the option is not a Pythagorean triplet. So which option is correct here? Option C is correct according to that question, but here which is not a Pythagorean triplet means 18, 79, 82. That is not a Pythagorean triplet. Okay, remaining these 3 also Pythagorean triplets only. How we can check that one also we discussed, no? So in this video we discussed up to 1 to 5 questions. In that next video leftover questions we will discuss. Okay.